I'm actually going to tackle 3F, the first one, and 3F, the second one, as if they were the same problem. Do you kind of see why I might do that? Because they're pretty much the same, except the number on the other side is different. Okay, and honestly, it's very much the same as 3E. We start off by doing the exact same thing. Let's look at, I guess we'll look at this one. This one you can see a little bit better. So we're multiplying everything by x minus 3 and x minus 1 to get the denominators to cancel. So it goes in the numerator of your two fractions, and then it just goes right next to the 1. This is something a lot of people were forgetting. They were forgetting to multiply it on the other side too. You have to do the same thing over here. Okay, see how there's a 2 here, and then it's 2 times x minus 1, x minus 3 over there. Okay, and then after that, there's kind of a step in here that's, it's not skipped, it's just not in as much detail as this one because it's the exact same thing, right? The x minus 1s will cancel in this one. The x minus 3s will cancel in this one. Multiply these out, you get x squared minus 9 again. Multiply these out, you get x squared minus 1 again. Here's the difference between the two problems. There's literally one difference between the two problems. This one's got a 1 on the other side. This one's got a 2 on the other side, right? Okay, so when you FOIL these out, you get x squared minus 4x plus 3.
How did you, wait?
When you multiply these, I can show you, relax. We get x squared, x times negative 3 is minus 3x, negative 1 times x is minus x, negative 1 times 3 is plus 3.
Okay.
Combine those two, we get minus 4x, yes? Okay. So the only difference, though, is when you have a 1 there, we don't really have to worry about it, right? Because when you multiply by something, you just get the same thing. When you multiply 1, you get the same thing. But over here, we had a 2. So you see how, look at what we have right here. We have 2x squared minus 8x plus 6. Okay? I'm going to kind of draw a little arrow to these two. So when we had a 1 in front, we got this. When we had a 2 in front, we got this. Do you see what we did with the 2?
You just multiplied it out, right?
Yeah, we just multiplied everything by 2 then at the end after we're done multiplying. That's the only difference. Yes, Amy?
Sorry.
That's okay.
Why can't you just do, I guess, actually not. Why couldn't you just, why didn't you do, for the second, like why didn't the 2 go here too? Like 2x?
Think if you had this. If you had 2 times 3 times 4, would you multiply the 2 times the 3 and the 4 and then multiply these two? Or would you just multiply 2 times 3 and then take that answer times 4? The second option, right? You would change this to 6 times 4 and you make it 24. You don't distribute when it's multiplication. So like it's what you're really doing here is this whole thing times this whole thing times this whole thing. You can either multiply these two first and then multiply by 2, or you can multiply by 2 and then multiply by the third one. Okay?
Got it.
So now here's the big difference in the two problems. When you try to get everything over onto one side in the first one, you end up doing 2x squared minus 2x squared when you get all of your x squareds onto the same side. And so you end up getting a linear equation over here. You don't have an x squared anymore. So there's no reason to use quadratic formula here because it's not a quadratic. There's no x squared left anymore. Okay, so this one just gets solved like normal. You try to get all your x's on one side, numbers on the other. So you end up getting 8x equals 16 and you get x equals 2. Over here, when you subtract x squared from both sides, because it's just 1x squared, you still have an x squared left. Okay? Once you've gotten everything kind of over onto one side and you realize you have an x squared left, what are your options for solving that problem? Quadratic formula or completing the square. Those are the two ways we know. I'd suggest quadratic formula, okay? I did not show how to use quadratic formula in here, but once you get that this equals 0, your a is the x squared coefficient, which is 1. Even though it's not written, we assume that's a 1. Okay? Your b is 4 and your c is negative 13. You just have to use the quadratic formula.
I wrote the formula up there.
Oh, and Brooke wrote the formula up there so we know what it is. And she definitely didn't put a negative before b squared.
No.
definitely not. Sammy.
I forget. When do you know? How do you know when you have to use either like quadratic formula or?
If there's an x squared, my suggestion would be try to get everything kind of over onto one side, like get it equal to 0. Because in most of these, you're going to have an x squared in there. But once you get everything over onto one side, if in this case there was still an x squared left, okay, and x squared indicates that it's a quadratic, you have to use quadratic formula. When we did that over here, both of my x squareds went away. I had 2x squared minus 2x squared. See how after I subtracted those, like right here, there's no x squared anymore. I have 0 equals negative 8x plus 16. That's linear. Okay, there's no x squared. I can't use quadratic formula on this. It's not quadratic. Okay?
Can you use split in the middle?
You could try using splitting the middle, but you see how we got some weird looking decimal answers for this one? You're probably not going to be able to use factoring or splitting the middle to do that because it's not going to factor. You'd have to find two numbers that multiply to negative 13 and add to 4. Do those exist? No, they don't. So you have to use quadratic formula for that one. You will only, if I'm remembering right on your test, guys, you should only have one that uses quadratic formula. That should really be about it.
How many? Is there a bunch that use formula for?
I don't even think, I really think I tried really hard to put only one on there that is actually a quadratic. So most of them, if I did it right, which I'm pretty sure I did, okay, and I'll be checking that before you actually take your test. Most of them should turn out like this, into nice normal equations, where you just put the line down the middle and try to get x by itself. That's really what most of them should turn out to be, because I don't want to make it a big test on quadratic formula. Plus, all your factoring skills, I'm already checking that throughout the test, right? Like you need to know how to factor on this test. Yeah? Like look at number 5. You end up having you had to factor out a GCF in C. You had to use difference of squares rule in D. You had to factor a lot in F. Like you have to factor a whole ton on this test already. So I'm trying to make the solving problems more about the process of solving and less about, do you know quadratic formula? Do you know this? Do you know this? Okay? Lauren, yeah.
So even if you can do the splitting the middle, can you just use a quadratic formula anyway?
Yes. Quadratic formula will always work. Solving with factoring, which is what people are, I think, talking about when they say split the middle, only works if you can actually factor it. So quadratic formula will work every time. Okay?
How do you use quadratic formula?
I can show you that individually if you want to. I don't want to take the time to go through quadratic formula right now, especially because it will be part of one problem out of many on your test. But if you don't remember it, I'm happy to go over that with you individually. Okay? All right.